Good morning, everyone. We are back for a new math lesson today, and today we are on lesson 9.7, which is going to be all about elapsed time. So let's start with our warm-up. On your piece of paper, I'm going to tell you a time, and I'd like you to write down what time it will be 15 minutes later and then 15 minutes earlier. So for this first one, if it is 2:25, write down what time it will be 15 minutes later than 2:25. It will be 2:40, 15 minutes later. Now write down what time it will be 15 minutes earlier than 2:25. It will be 2:10. All right, the next two problems, imagine that it is 6:55. 6:55. What time will it be 30 minutes later if it's 6:55? It would be 7:25. What time will it be? Would it be 30 minutes earlier than 6:55? Going back 30 minutes. It would be 6:25. Let's do two more, a little harder. This time I want you to imagine that it's 8:27. 8:27. If it's 8:27, what time will it be in 25 minutes? 25 minutes later than 8:27. It would be 8:52. And you might have thought that 25 and 25 is 50, and then because it was 27, you'd need to add on those 2 more minutes. If it's 8:27, what time would it be 25 minutes earlier? It would have been 8:02. All right. You don't need anything except to look at the screen for the next thing we're going to talk about. So I'm about to show you some graphs, and these graphs show the length of day, meaning the amount of sunshine in a day, for two places, Reykjavik Island and Tierra del Fuego, Argentina. Reykjavik, Iceland, I should have said. So if you imagine Iceland and Argentina on the globe, you might know that they're kind of on opposite ends of the globe. Iceland is toward the North Pole, and Argentina is closer to the South Pole. So let's take a look at the two length of day graphs. You can see the graph on the left is length of day for Iceland, and the graph on the right shows length of day for Argentina. So when you look across the bottom, these are dates. So it starts with 9/4, that would be September 4th, and it goes to 6/24, which means June 24. And then same thing here for Argentina, starts at September 4th, goes through June 24th. So when you're looking at the Reykjavik graph, the graph on the left, what is the shortest day, the shortest amount of sunlight? What day? So the hours you can see here go up the side. So we are looking for the day that goes up the shortest amount. And you can see that it's about here. What are those days when we come down and look at the dates? It's December 18th and December 25th. Those are the shortest days. Because Iceland is in the northern hemisphere, it's in the north half of the globe, in the winter is when they get the least amount of sunshine. Let's go over and look at Argentina's shortest day of the year. So again, you're looking at the number of hours going up the side, and so the lowest number of hours of sunlight is, interestingly, June 24th. So it's kind of the opposite of Iceland. Iceland's shortest day was in December, but Argentina's shortest day was in June. Now let's look at the longest hours of sunlight. In Iceland, which day or days have the longest amount of sunshine? Yeah, all the way up here with about 21 hours of sunshine. Can you imagine? That means it's almost sunny all the day long in June 17th and June 24th. Now come over to Argentina. Let's look where the most amount of sunshine is in Argentina. Yeah, it peaks its highest right about here at about 17 hours, and that is December 18th, December 25th, the opposite of Iceland. So in the northern hemisphere, when the days are long, then in the southern hemisphere, the days are short, and then it flip-flops. When the days are long in the southern hemisphere, the days are short in the northern hemisphere. And it's super interesting that the closer you get to the North Pole and the South Pole, the longer the days are when it's sunny, and the shorter the days are when it's not so sunny. Almost 24 whole hours of sunshine when it's the sunniest, and almost no sunshine when it's the darkest. All right, your job today is going to be to look at, and I'll show you here, this map, which I'm posting on our website and you can print if you'd like to. It is the sunrise and sunset data for different cities around the world on June 21st, 2016. So when you look at this map, if you took, for example, Toronto, Canada, you can see that on that day, on June 21st, 2016, the sun rose at 5:37 a.m. and the sun set at 9:02 p.m. Or if you looked at Manila in the Philippines, you can see on that day the sun rose at 5:28 and the sun set at 6:27. You're going to use this map to answer questions on journal page 291. 291. So it looks like this. It says calculating the length of day. Use open number lines, a toolkit clock. You can use your e-toolkit clock if you'd like to help you calculate the elapsed time. Use the sunrise and sunset data from Student Reference Book page 281. Well, since I know you don't have Student Reference Book page 281, I've posted it below. It's that world map that we just looked at to help you answer these two questions. The first one says, find the length of day for Esperanza Base, Antarctica on June 21st, 2016. So you would go back to the map that we were just looking at. In this time, you need to find Esperanza, Antarctica. You'll write down sunrise, you'll write down sunset, and then you need to figure out how much time between that sunrise and sunset, and you'll write that here for elapsed time. Then for number 2, it says, find the length of day for another location. You can pick any other city on the map, write it down here where it says location, write what time the sun rose, write what time the sun set, and then use an open number line and write down how much time between sunrise and sunset. So you're going to complete this journal page 291 and then go ahead and work on Math Boxes 9.7 and later today, Homelink 9.7. Have fun, and I'll see you back here tomorrow. Thanks, friends.